Hi, Mr. Richards here. Today's algebra lesson is on transformations of quadratic functions. Before we get into our first example, we need to ask ourselves, what is a transformation? Well, transformation can be defined as a movement of a geometric figure that changes the position or size of a figure. And the first transformation we're going to have today is the translation. And a translation moves a figure up, down, left, or right. It does not change the size or does not turn the figure either. It just moves and slides the figure up, down, left, or right. And you can see in our key concept box of vertical translations, this graph, f of x equals x squared plus k, is the graph of f of x equals x squared, but just translated vertically. So if I have x squared, but then I'm adding something to that, it's going to translate it vertically. Now the first one is just f of x equals x squared. But if my k is greater than 0, it's going to translate that many units up. If the k is less than 0, it's going to translate that many units down. So describe how the graph of each function is related to the graph of f of x equals x squared. Well, if we look at our 10 here, our k is 10, and that is greater than 0, so we're going to be translating up. And so we will translate 10 units up. What about our next example? We have this minus 8 here, x squared minus 8. So our k is equal to negative 8, that is less than 0. So we're going to translate 8 units down. The first example was vertical translations. This is horizontal translations. So the graph of g of x equals x minus h is the graph f of x equals x squared translated horizontally, so left and right. If this h is greater than 0, the graph of f of x equals x squared is translated h units to the right. If it's less than 0, we're going to the left. And it's the absolute value, units to the left. So here we have g of x equals x plus 1 squared. Well, our k from our previous example would be equal to 0. Our h equals negative 1. And you're saying, wait a minute, that's a 1. Well, remember, we have x minus h squared as this rule. And since this is a plus 1, the h is really a negative 1. And so what this is going to end up being is a translation one unit to the left. Next we have g of x equals x minus 4 squared. And so once again our k is going to equal 0. And our h this time equals 4. Remember, this is in the form x minus h squared. So this is going to result in a translation translated 4 units right. So it's almost the opposite of what you'd think. And now we get to combine g of x equals x plus 1 squared plus 1. We're getting combine our vertical and our horizontal translations. So our k in this example is equal to 1, and our h is equal to -1, since it's the opposite of that. So this is going to be translated 1 unit up and 1 unit left. And in example B, our k is going to equal -2, so we'll be going down, and our h equals a +4. So this once again is going to be a translation, so translated 2 units down and 4 units right. And now we get into dilations. What is a dilation? A dilation alters the size of a figure. If you think about your eyes being dilated, your pupils change in size. And with these quadratic functions, it makes the graph narrower or wider than the parent, which is the original graph. And you can see in our key concept box where the blue is the original, when A, this number here or here, is greater than 1, it is stretched vertically, and you can see how that gets stretched vertically. If it's between 0 and 1, like it is in example A, it gets compressed vertically, which is our green graph there. So describe how the graph of each function is related to the parent function f of x equals x squared. Well, here we have our a being 1/3. And since that's between 0 and 1, we can describe this as a vertical compression. In our next example, we'll have a being 2, but then we also have this +1 here, so our k is 1. So we'll have vertically stretched, but then we need to remember our translation here, so we'll write and translated 1 unit up. Next we have our reflections. Well, what do reflections do? They flip a figure across a line. So, in our key concept box, if it's the negative f of x, that will be the reflection across the x-axis, and that is our in red. If it's the f of negative x, that's a reflection across the y-axis. Describe how the graph of each function is related to the graph of f of x equals x squared. Well, this is a positive 1/5, which actually is going to go back to our dilations. So a equals 1/5, and then we have this -7 here, which deals with our translations, so k equals -7. So we are going to have this graph being compressed vertically due to our dilation, and translated then 7 units down. And then in example B, we have g of x equals -3x squared plus 1. Well, this plus 1 is our k, so k is 1. And our negative 3 here means we are going to be reflecting across the x-axis. We are going to be stretching vertically, since that is a 3. And we are also going to be translating 1 unit up. So 3 things there. And so we can tie this all together in this test question, which is an equation for the function shown in the graph. Well, we have moved down 2 units. So we should expect a negative 2 here, which eliminates C and B. Then we have to compare our 1/3 with our negative 3. Well, this negative would mean that we should expect some kind of reflection over the x-axis. And since this is not a reflected figure over the x-axis, D is now also out. So that leaves us with our answer of A. And that's it for this lesson on transformations of quadratic functions. Good luck.